electron is removed, the outer shell drops inside or it comes inside. When the outer orbital electron replaces the displaced electron, a photon is emitted. Now see here, the energy is converted from higher accelerated electron, a kinetic energy, into the photon, which is different in two orbital binding energies. What it means? There is a difference between two orbital binding energies. Inner one will have higher, lower one will have, the outer one will have lower. So when the more inner the electron is displaced, there will be more energy exchange. However, it will require a more energetic or electron with more kinetic energy to hit it or to replace it. The energies of characteristic photons are discrete because they represent the difference of the energy levels of the electron orbit level, hence are characteristic of the target atom. So always we will have to select a target in such a way that it will produce a good characteristic radiation. Now it contributes only to a small fraction of photon in an X-ray beam. The incident electron ejects an inner electron from the tungsten target. It causes atom to become ionized. Now electron from outer orbital attract to void in the incident inner orbit. The energy in the form of characteristic radiation is released. Now we will see it again, that is the generation of characteristic radiation. Incident electron interact with K shell. K shell electron is removed from, if the energy of the incident electron is greater than the K shell binding energy. If the K shell binding energy is more, it cannot be displaced. So it has to be, K shell electron has to be lower energetic than the incident electron, and then only it can create a vacancy in the K shell. Now the electron from the adjacent A shell fills this vacancy, it falls inside. Now K alpha characteristic X-ray photon is emitted with energy equal to the difference between the binding energy of these two shells. Now here it is diagrammatically shown. Now we are seeing that yellow one is the incident accelerated electron which hits the K shell. Now once the K shell is displaced, the electron from L shell will fall inside. Now the specific energy is characteristic of the target material. Now whichever material you are using, it will be characteristic of it. Now here we are seeing it again in more detail. You are seeing the K shell electron is hit by a accelerated kinetic energy electron and it is displaced. Once it is displaced, then the electron from outer shell falls inside. Now K line are the diagnostic important line. L lines are too little. Now the X-rays coming from K line, they are of diagnostic importance, and the X-rays which are coming from L lines, they are of too low energy. Now what happened to them? The low energy will either get scattered, they will be absorbed by the inherited filters in the tube that we have seen in the tube chapter. Now the one which will have a higher energy will leave the tube. Now bombarding high speed electron must have sufficient energy, that is 69.5 kV, that is the critical voltage that depends on a K line. Now this energy level is less than that, they will not be able to be useful in a diagnostic range. Now in dental it is between 50 to 90. Now here we are seeing from where the characteristic radiation come.